Welcome to the video covering Lesson 4.3, Using Proportions. Let's start with some vocab. The scale factor is a relationship between the size of a model and the actual size of an object. We will be using this relationship in some problems later on in the notes. This example says the ratio of children to adults at a holiday parade is 5:2. If there are 1,440 adults, so 1,440 adults at the parade, how many children were there? So what I want you to pay attention to first is this ratio of children to adults, because that does tell us that we want to have children over adults. And I'm going to go ahead and put it as a fraction because I'm going to be using proportional relationships here, and writing it as C:(A) is not wrong to represent this relationship, but it's not going to help me mathematically. So if I have C to A, and then I just set that equal to this 5:2. So the order matters. So children to adults is 5:2. And I hope that makes sense for this situation, that there's a holiday parade. There's going to be more kids than there are adults. So children to adults is, that means equals in math, 5:2. Then we can go ahead and figure out where this 1,440 gets plugged in, and that's just going to use the label of adults. So I'm going to leave the C, but now instead of A, it's going to be 1,440 equals 5/2, and then we use our cross multiplication to solve for C. So after cross multiplying and dividing, I get C equals 3,600. So there were 3,600 children at the parade. This question is very similar in the fact that we're just comparing two different types of people. Last problem was children to adults, and now it's whiners to complainers. So whiners to complainers in that order is going to give me that fraction, 3 to 5. Again, order matters. Whiners came first, that's on top, so the 3 comes first, that's on top. Complainers was second, that's on the bottom. The 5 was second, so that's on the bottom. Then I use the information that's given to me here, 21 people whining. So 21 whiners. I'm going to put the 21 where the W is, leave the C for the complainers, and then that's what I end up solving for, and I can answer the question of how many people complained. So after cross multiplying, the dividing gives me C equals 35, so there were 35 complainers. Example 3, it takes 5 cups of flour to make 2 pizzas. To make 10 pizzas for the party, how much flour do we need? Hope you guys are starting to see a pattern here with these sort of proportional problems. There are 3 numbers and 2 labels: flour, pizzas, pizzas, flour. So those are our 2 labels, flour and pizza, cups specifically of the flour. And then we have 3 numbers, 5, 2, and 10. And that's going to be pretty consistent with these proportional relationships. So it takes 5 cups of flour to make 2 pizzas, and I like to put just a little label next to it. This is not multiplication. It does not mean 5 times C, it does not mean 2 times P. This is just labeling 5 cups to 2 pizzas, and then that's going to equal, well, the 10 is my label on pizzas, so that's going to equal so many cups for 10 pizzas. So just to clarify, I'm solving 5/2 equals C over 10. I don't need those extra letters in there. They're not representing any multiplication. They were just labeling. And then I'm going to go ahead and quickly cross multiply and divide to figure out how much flour we need. So after cross multiplying and dividing, we get C equals 25. So that's 25 cups of flour. So this problem says you are following a recipe for a party punch. The instruction says 3 parts fruit punch to 4 parts lemon lime soda. If you have 6 pints of fruit punch, how much lemon lime soda do you need? How much total party punch will that make? Okay, so the only thing I wanted to add in really quickly here is the fact that if you look at this problem, it talks about the ratio of the fruit punch to the lemon lime soda being in parts. And what that allows you to do as the person who's creating this recipe is to use whatever size you are making. So let's say you're making a small batch and you're only using like ounces or cups, or you're making a larger batch and you need like gallons and liters, and it just allows you to make whatever label you have the one that you need. So that's why it says 3 parts to 4 parts. It doesn't matter what the parts are, but they do have to be the same. So in other words, you can't have 3 gallons of the fruit punch to 4 cups of the lemon lime soda, because that is not the correct ratio. That's not the correct relationship between those two things in the recipe. So the parts are allowed to be whatever they want as long as they are the same. So setting up this proportion equation would look like 3 parts of fruit punch to 4 parts lemon lime soda. 6 is going to go up top, and I'll make an L at the bottom. So the 6 is going up top because that's the fruit punch, and then the 3 represents the fruit punch, and then we're going to cross multiply and solve here. So this one ends up being 8 pints of soda. Now, as far as answering how much total party punch will that make, we have to then go ahead and add the 6 pints that was in there of the punch. I guess I should say the fruit punch, since we're making a party punch. Don't want to just say punch. So 8 plus 6 would be 14 total pints of party punch. The perfect color purple uses a ratio of 2 to 3 for red to blue. If we need a total of 8 gallons of this perfect purple paint, how much red paint goes in? So if we look at the ratio of 2 to 3 for red to blue, based on the problems that we've been doing so far, we would make it a 2 over 3. But it is important in this particular problem to pay attention that that is 2 over 3 represents the red to blue, but our label it's a total of 8 gallons of the purple. So the 8 represents the whole total purple paint. And so this becomes an issue now where we can't just use the 2 and the 3 and the 8 that's given to us. Instead, I need to add the 2 plus 3 together to make it 5. So this is going to be the total. So 2 red plus 3 blue would be 5 total, whatever it is. Again, the same pints, quarts, gallons, whatever it may be. This is what we would create with, we would have 5 total whatever if we had a ratio of 2 to 3. So because we want to figure out how much red paint goes in, we want a ratio that reads red to purple equals red to purple. So we're not actually going to put the number for the blue in there at all. So this will look like 2 to 5 equals R over 8. So I'm putting the 2 with the 5 because the 2 comes from this 2 to 3 relationship that gives me the 5 total. So if I have 2 parts red, that will give me 5 parts of the purple. How much red will I get, or will I need, in order to get 8 gallons of this perfect purple paint? So we're going to cross multiply and solve this. Now in this problem, cross multiplying gave me 5R equals 16 divided by 5, I get 3 1/5. So because you can't buy a fifth of a gallon of paint, I'm going to go ahead and say that we are going to need to buy 4 gallons of red, but we're just not going to use all of it. But we do need to buy 4 gallons of red paint. But the most correct calculated answer is that we need 3 1/5 or 3.2 gallons of the red paint to get the perfect purple for 8 gallons. This last set of problems actually starts to use this idea of scale factor that we talked about with the vocab earlier, a relationship between the size of a model and the actual size of an object. So models are something you guys have seen before. There are models, cars in the stores, there's model buildings all over the place. And so blueprints are another example of a model drawing as opposed to a three-dimensional model. So there are lots of different ways that scale factor gets used. And then this first example, it says the general contractor is following a blueprint to build a dresser. The drawing has a scale of 1 centimeter to 2 feet. That's going to be our ratio. That's going to be our fraction. Then it says if the height of the dresser on the blueprint is 2.25 centimeters, how tall is the dresser going to be in reality? So again, there are two labels, centimeters and feet, so drawing to actual, and then we have three numbers, 1, 2, and then 2.25, and so that's going to give us 3 out of our 4 spaces in our proportion equation. So using this proportion equation, we're going to go ahead and cross multiply and solve. Please make sure you do have labels on all of these real world answers here. This X does represent feet. I can see that in my proportion equation, but also the fact that the question says, how tall is the dresser going to be in reality? So in real life, the dresser is going to be 4.5 feet. And I believe this is height, so 4.5 feet tall. An architect needs to build a model of a proposed building to show his bosses. His model will use a scale factor of 1 inch to 32 feet. If the real building is going to be on a stretch of road that is 550 feet, how long of a road does the model need to be? So let me show you some examples here of some scale models. This is just a screenshot of results when I Googled scale model. And the reason why I wanted you to see is the actual, this is a scale model of some structure to her actual human being back there. But even if we have a model of a building, sometimes the model needs to include the road information around it. See, there's a road right here in this structure. Here's the road frontage on here. And people do this for a living as they are proposing different neighborhoods or construction projects, industrial areas, commercial areas, whatever the case may be. And in order to really sell it, you need to make sure that it actually does fit on the road that you're going to be building it on. So that's why it's important to be looking at the whole picture. Now that we have that basic understanding out of the way, we can take a look at the proportion equation using the scale factor of 1 inch equals 32 feet. I'm going to put the 550 feet in the bottom and my X number of inches will be at the top. So this is using the scale factor of 1 inch on the scale represents 32 feet in real life. So how many inches in the model will I need to represent a 550 foot road? Okay, so when we're dealing with inches and feet and we get an answer like this decimal, notice I did not round it, and I did not round it because this is inches, and if we look at this, this actually ends up being, if you turn it into a fraction, use your calculator, whatever you need to do, turn it back into a fraction, it ends up being 275/16, which that's actually good news because inches are measured in 16ths. So this simplifies, and I'm simplifying it down to a mixed number because that's how we would actually be measuring it on a ruler. So this ends up being 17 3/16 of an inch, and that's how long the roadway would be in the model. So these problems have a part A and part B, so it's going to be using that same scale factor of the 1 inch to 32 feet. So keep that in mind here. It says how tall is the building model going to be if it needs to be 95 feet in real life, and if the height of the light pole in the model are 7/16 inches tall, how tall are they in real life? When I do these problems, I do find it very helpful to include the labels in the math problem, but as long as you understand that they are only labels and they're not multiplying or anything, it's not 1 times inches or 32 times feet, it's 1 over 32 equals X over 95, and that's what we're solving. So this first problem ended up giving me this decimal. Again, I'm not rounding here because I am dealing with inches, and so I wanted to see first what kind of fraction it gave me, and it does give me 2 31/32 of an inch. Guys, that you can see by the decimal and 31 to 32, it's so freakishly close to 3 inches that I would be okay with this approximately 3 inches. I'll be honest, in the real world, if you're actually drawing the model or creating the model, you might actually need to pay attention to the fact that it needs to be 31/32 of an inch, but for us, we can just say approximately 3 inches. Now the second problem here, this is the first one we've had to find feet. We know the inches, and with this one it's 7/16 inches tall, so this looks awfully confusing having this fraction within this fraction. But when you're cross multiplying, like that's the only time that you need to actually use the 7/16 as a fraction, is when you're doing that times 32. Just make sure you're using a calculator, because in this problem especially, that just multiplies nicely. 7/16 times 32 is 14, and so x equals 14 feet. That's how tall the light poles are in real life.